to those later, but if I tell you to click on the Insert tab on the ribbon, that's what I'm talking about. So now we're going to look at the basic use of Excel as a calculator. Remember, you'll really see why this is useful in a little while, but let's just get to grips with using Excel as a calculator. Each one of the cells in Excel, where the rows and columns meet, little boxes, is an individual calculator. You can of course store words and text in those boxes as well. And so if you're telling Excel that you want to perform a calculation, you've got to tell it that it is a calculation. And the way to do that is to use the equals sign. So if I want Excel to do the equation 3 plus 2, I need to type equals 3 plus 2. And when I press enter, I'll see the answer pop up in the box. And that's great. But if I need to see what formula is generating that answer, how do I do that? Well, I click on the cell, and up in the formula bar, the original formula appears. And so you can always see in Excel what is causing that number to be generated, the maths behind it. Okay, so that was addition. Here is how to do the multiplication, division, and subtraction. As you can see, the addition and subtraction symbols are plus and minus, which are up in the top right of your keyboard. The multiplication symbol is an asterisk, which is shift and number 8. And finally, the division symbol is a /. All of that's pretty basic math. So how do we do something that's a little bit more complicated? Something like this. Well, here's a formula that occurs across 2 lines. And in just the same way that you can't type that into your desktop calculator, you can't type it into Excel. And so what we're going to do to allow it to be written on one line is to use brackets. And it's exactly the same as you do with your pocket calculator. Now, how would we use exponents? So 2 to the power 2 or 5 to the power 3 or those kind of things. Well, again, we can't write that. We need to write that on one line for Excel. And so the way we do that is using this little up arrow symbol, which is shift and number 6. It's called a caret, that symbol. And finally, a neat little trick for science students, it's quite useful, is using standard form, scientific notation. Say you wanted to write 3 times 10 to the 8. You could use the caret symbol again, so you could do 3 asterisk 10 caret 8. But there is a neat little trick. You can just use a capital letter E. It's the same as on your calculator again. If you wanted to type 3 times 10 to the 8 on your calculator, you type 3, hit the capital E, and then type 8. It's exactly the same in Excel. So now we'll go ahead and open up the first of our data sets. This is dataset 01. If you haven't already downloaded the datasets, go and do so now. The link is in the blurb below this video. Once you've got it loaded, you'll see something that looks like this. This is a spreadsheet which contains a recipe for chocolate chip and almond cookies. Please don't try making the recipe because we don't actually know whether it makes passable cookies or not. So now you can see the spreadsheet with the recipe in it. You can see that it's not laid out in the way you might typically lay out a recipe. Typically you might have the largest ingredient come first. In this case that's flour, followed by the butter and sugar and things, going into smaller ingredients. But these are in a funny order, and that gives us a nice excuse to introduce you to sorting in Excel. Sorting allows you to rearrange a set of columns, rearrange a set of rows based on the data in the columns. This makes sense in a moment. Basically, we can reorder everything in this table based on the amount of it that we're using in the recipe. So the first thing to do is to go ahead and select cells A3 to D7. Click on the Data tab in the ribbon, and then click on Sort. Now, if you click on the Sort button in the Home ribbon, which is called Sort and Filter instead, you still get here, but you need to click on Custom Sort. One interesting thing to note is that up in the top right there's a tick box which allows you to select whether or not you've contained headers in your data. See, if we'd have selected rows rows 2 down to 7, then we would have had the headers in, and we need to tell Excel that it's not going to sort those, otherwise your headers might end up halfway down your page. So now we've got this window open, we can tell Excel that we want to sort by a particular column, and we want to sort by column B, and then we can tell it that we want to sort from the largest to smallest. And then when we click OK, our table will suddenly look much more like a convincing recipe. I still don't know if it makes good cookies. Now we're going to move on, and we're going to calculate the cost per recipe of each of the ingredients. Now you can see the formula here on your screen. This is basically how we're going to calculate the cost per recipe. Now if you care about how to calculate the cost per recipe and you care a bit about maths, then you'll see that this makes sense. We've simply worked out what fraction of a package we've used and then worked out what the cost is for that fraction of the package. If you don't care about the maths and how we derive this, then just don't worry about it and trust us that the correct formula you need to put into the cell in column E in order to calculate the cost per recipe for the flour, say in E3, is equals open bracket B3 slash open bracket C3 times 1000 close bracket times D3. The reason we've got the multiplied by 1000 in there is simply to change between grams and kilograms, and kilograms to grams, sorry. And again, if you care, then you'll understand, and if you don't worry about it. So now we've got a formula in cell E3 which calculates from the cells to the left of it what the cost per recipe is. And we want the same formula to be repeated all the way down that row, but to use the appropriate cells, either ones to the left of it, not to use the ones in the top row again. Luckily, there are two nice ways to do this. One is to click the little tiny black dot that appears in the corner of the cell and hold your mouse button down while you drag across down the column, and then let go, and you'll see the formula has been copied down. And if you click on any one of those cells, you can see the formula in the formula bar, and you can see that in each one of those cells, as we go down, the formula has been adjusted so that it references the cells to the left of it. Excel's quite smart that way. The other way to do it, so if we just undo what we've done here, the other way to copy those cells down is to click on cell E3 and then copy using Control-C, and then select the cells below it and paste using Control-V. And again, Excel figures out what you want to do, makes all the adjustments for you, and saves you a lot of time. You only have to do the formula once instead of a bunch of times. Great. So we are going to come on in a moment to calculate the GST component, but before we get there, we're going to format the cells. You see, all the cells in the last two columns here should be currencies. They should be dollar values. So you should have a nice dollar symbol and two decimal places. And currently we just have numbers. And of course, they mean the same thing, but it's much easier, much nicer to have the spreadsheet showing numbers. And this is a good excuse for us to show you how to format cells. So, if you select the cells you want to format, and then right-click on those in that selection, and hit Format, we can format the type of, we can tell Excel the type of data that's in those cells. In this case, we want to tell it it's a currency. Now note that while we've got this window open, there are all the tabs across the top, which means that we can format different things like the font, color, and size, and all of those things as well. Once you select a currency, you'll see there are lots of options on the right. We don't need to change any of these, but they allow you to do all kinds of clever things with changing the currency color if it's a negative value and that kind of thing. So let's click OK, and we'll notice that all of our cells are now nicely formatted as currency. Now we want to calculate the GST component in the final column there, column F. But before we do that, we need to have a quick look at how Excel handles percentages. It handles percentages a little bit differently from what you might expect. It handles all percentages as fractions. So I'm sure that you remember being taught in high school that 15% can be represented as the decimal 0.15. And that's exactly what Excel does. Excel stores all percentages as decimals, and that allows it to do all kinds of calculations much more easily. So you can just multiply things by a percentage to find out what the percentage of the thing that you've multiplied is. So what you need to be aware of is that if you format a cell, like we did for currency, to make it a percentage, and you then type in a percentage, it's all good, but Excel will store that as a decimal. So if you then want to multiply something by it, you don't need to do any sort of dividing by 100. So let's go ahead, and in cell I1, we're going to put the value 0.15, because we know that Excel is going to handle it that way anyway. Now, for our ease of use, we want to see that as a percentage. So let's right-click on that cell and select Format. And then we can select Percentage and click OK. And now Excel's realized that we wanted a percentage, and it's put 15% in that box, which is very helpful. Now we can go ahead and we can calculate in F3 the GST fraction of the money that we've spent on the recipe. So we simply need to tell it to multiply E3 by I1. And that's the GST fraction. GST component. That's all well and good. Now if we go and try and drag that formula down through all those cells in that column in the same way that we did previously, something goes wrong. Now if we click on one of those cells, we can see, looking in the formula bar, that what it's done is copied the references down as we expected it to, but including the I1 reference, and has become I2, I3, I4. And of course we only have the GST rate, 15%, in the one cell at the top. And so we need a way of telling Excel not to adjust that reference as it adjusts the formula. Luckily, there is a nice way to do this, and what we need to use is a dollar symbol. So if we undo this copying initially, and we go back to our first cell, the cell that worked, F3 has this formula in that works. Now we need to tell Excel that as we copy that formula down, we don't want it to touch the reference to cell I1, such that the reference will stay the same all the way down the column. And we use a dollar sign to say, hey, Excel, don't touch this. And we can put the dollar sign either before the letter, the column reference, or by the number, the row reference. Now in this case we can do both, but just to show the flexibility and power of this, if we just put the dollar sign in front of the number 1, like so, then our formula still works, everything looks the same. Now if we drag it down as we did before, and then look at the cell formula in the formula bar by clicking on one of those lower down cells, we'll see that that 1 has been left alone. Excel has left it alone. Now if we dragged one of those formulas across to the right, Excel would still change the letter component of that cell reference. We've only prevented it from changing the number component. So if we wanted to ignore that reference altogether and to leave it well alone, we'd put a dollar sign in front of the I and a dollar sign in front of the 1. In this case that would work, but it's not really necessary. So you can lock the rows and columns independently. Great. So now we have calculated everything in the spreadsheet apart from the totals at the bottom. You see there's a little totals heading, and we haven't got any totals. So to calculate totals, we're going to teach you about functions. Functions are a great way in Excel of wrapping up a whole lot of complicated maths into a simple, easy to use package. There are lots of things that you can calculate by doing the appropriate maths, and you can calculate over and over again. You might want to calculate averages, or you might want to be more complex than that and calculate confidence intervals or t-values for a t-test. Now, all these sorts of things involve quite a bit of maths, but there are easier ways to do them in Excel, and that's what functions are for. Functions basically consist of a keyword and then any numbers that you need to give to the function. So as you can see here, the average function can be used to give you the average of some data. And the average, the data that you're giving it, you can either give to it as a list of numbers like this, or you can give to it as a cell reference. So you can tell Excel, I want the average of all the data between cells A2 and A52, or whatever it is that you like. We're going to use the function sum here, and the sum function, SUM, tells you the total of all the values in a range of cells. So we're going to start by getting the total or amount of stuff that we're using in the recipe, the total number of grams. So we're going to go equals sum, open brackets, and as soon as we open the brackets, Excel wants us to give it a list of cells or a range of cells. So what we're going to do is we're going to click on cell B3 and then drag down and give it the full reference, give it the full list of cells we want the total for. Then we're going to close brackets and hit OK. Now if we click on that cell, we can see what the formula looks like in the formula bar. That makes sense. That's our sum function and all the cells that are going into the sum function. And we can see the output, the total number of grams that we're using in our recipe. Now we can drag that cell all the way across the columns, drag it along the row, across the bottom of all the columns, and it will give us all of our totals. So great, that's our recipe spreadsheet finished with. We've got all of the data we can calculate calculated. We've used basic functions, we've done basic maths, and so well done. If you've stuck with us this far, you've done all sort of basic maths in Excel. We're going to get a little bit more complicated in the next couple of data sets, but don't worry about it, it's not too hard. So if you want to open dataset 2, we'll move on with that. So this is dataset 2. Dataset 2 is really just nothing special. It's an excuse to show you a couple of things that happen when you move data around. So it's quite useful, but it doesn't need really any explaining. Column A and column B are just random numbers which are multiplied together to give you the numbers in column C. So let's start by looking at what happens if we copy cell C6 and then paste it into C7. We get the answer we'd expect to get in C7, and if we click on the cells and look at the formula in the formula bar, we can see that Excel has, as we've shown before, adapted the formula into C7 and gives us the correct answer. Now let's undo that, and then let's cut cell C6 and paste it into cell C7. See, what's happened here is that Excel has moved the formula and it has left the references alone. Now, what Excel is doing is it's trying to make sure that if you cut and then paste cells, everything still works exactly as it did before. And we'll demonstrate that if we just undo that. Now, if we select all of column A and we cut it using Control X, and then we paste it into column F, our formula in column C, all the formulae in column C have been adjusted, and they all now point to cells in column F and B, and it multiplies those together. See, Excel has said, hey, you've moved this column, but you want the formula to still make sense. You still want them to add stuff up. And so they do. Whereas if you copy cells and paste them, Excel says, you're making more of the same. So instead of pointing to the original locations, I'm going to adapt and move with you and point to new locations, which is why we can copy our formulae down a column or along a row, and they will adapt, and the new formula will make sense. They won't calculate the same things as the old ones. And so to show that, we'll do what we've done before. We'll finish column C, we'll copy it down, and everything makes sense. So feel free in Excel to cut tables of data or to cut blocks of formulae or blocks of data and move them around. And if you move them around by cutting and pasting, Excel will keep up with you. It'll know what you're doing and it'll make everything still work. If you copy, things can go wrong with your formulae, but on the other hand, copying is very, very useful for making sure, not having to type formulae over and over again. That's all with dataset number 2, so go ahead and open dataset number 3. So this is dataset number 3. This is experimental data from an experiment to do with growing yeast. And in the experiment, yeast were grown in different size beakers. Some of the beakers were tall and thin, some of them were short and fat, and everything in between. And the point was to see if the growth rate of yeast was any different when it was grown in these beakers of different dimensions. So in the first 2 columns, you can see that we've got the diameter and the depth of the beakers. where the yeast was growing. And in the next two cells, we have the growth rate as determined by a sensor. And the sensor was either sensor A or sensor B, and that's what's in the last column. So we're going to do some graphing, but before we can, we need to get some summary data. First of all, we want to know the volume of the beakers that the yeast was grown in, and we want to know we want to sort out the data because there was something wrong with sensor B, and we'll explain that in just a moment. But first of all, let's create some column headings under which to put our data. So let's merge two columns here. So we click Merge and Center on the Home tab, and then we can type in summary data. And then in column F2 we can write volume, and in G2 we can write growth. And those are our column headings. Now we want to calculate the volume of a cylinder, and that formula needs to go into F3. The volume of a cylinder is calculated by pi r squared times h, which is the height. And so the formula that we need ends up being pi times, open brackets, A3 over 2, close brackets, squared, so that's caret and then 2, times B3. Now let's just have a look at this formula in the formula bar. Now, first of all, the reason that we've divided A3 by 2 is because A3 was actually the diameter, so divided by 2 gives us the radius. Pi is a function, you'll see by virtue of the fact that it's got a label, the name is pi, and then an open bracket, close bracket. And it's just like the other functions that we've used, except that with pi, you obviously don't need to give it any numbers. You don't need to tell it anything. But because functions are structured the way that they are, it still has to have the open brackets and then the close brackets. And the rest of it we've done before. So if you care about geometry and you care about the fact that pi r squared h is the way to calculate the volume of a cylinder, then you'll follow this maths, and if you don't, then that's the formula you need to use, and that's just the way it is. Now, we're not going to copy that down just yet because we want to calculate, we want to put a number in the column next to it under volume and growth, and then we'll copy them both down together. Now, the difference between sensor A and sensor B in terms of detecting the growth rate of the yeast is that sensor B was reporting a value that was 2.4 times too large. So wherever the data was collected by sensor B, we need to divide the value in C3 by 2.4. We don't need to do that if it was collected by sensor A. And so we need to be able to distinguish between those two sets of data. And so we're going to use a logical function. Now, logical functions in Excel are very powerful, and they are conceptually the hardest thing we're going to do in terms of Excel maths in this tutorial. So stick with us, get through this, and then we'll move on to pretty graphs instead. Well, we're going to use the if function. Now, if is a way of doing one thing if a certain condition is met, or else you do something else. So if the data was collected by sensor A, do this. Otherwise, when it's collected by sensor B, do something else. So in this case, it's really quite easy. We're going to do if, open brackets, D3 equals A, and the A has to be in speech marks. The reason the A has to be in speech marks is because A is a letter, it's a string, it's a bit of text, it's not a number, it's not a numerical value. And whenever you're dealing in logical functions or in any formula in Excel with text, we need to put it in speech marks. So we put a comma, and that tells Excel that we've done the conditional statement, and we're now doing the then. So the phrasing that you need to think of is if, then, else. If something, do, then something else do a third thing. So our then is just C3. That is, if the sensor is sensor A, then just give me the value that's in C3. You don't need to do anything to it. And then another comma, and in any other case, i.e. when it's collected by sensor B, we need to divide C3 by 2.4. So now C3 divided by 2.4. And now we close brackets and press enter. Now we can copy both of those formulae all the way down the column. And what we'll notice if we look down the growth column is that wherever the sensor used was sensor A, then our growth is exactly the same. Our if has just said, yep, it's sensor A, don't need to do anything to it. And wherever it was collected by sensor B, it's roughly 2.5 times smaller because it's actually been divided by 2.4. Great. So that's the hardest thing we're going to do, and you've just done it. We've got through the data manipulation. Now what we're going to do is do some graph plotting. So we are going to select all of the data that we've just made, all the summary data, as well as the two headings at the top of that column. If you're just plotting XY data like this, Excel does a pretty good job of interpreting what those headings mean and putting them in useful places. So we like to select them. Then we're going to click on the Insert tab up in the ribbon. And then over here you can see where all the charts are. And in the bottom middle, there's the one that looks like an XY scatter graph. And so we're going to click that. And then we're going to click the top left graph and get it to plot an XY scatter. And as you can see, if all goes well, and if you've manipulated your data correctly, you'll get a pretty smiley face. There are not many data sets that give you a smiley face when you plot them. Now, if your graph is selected, you can see that up in the ribbon you now have two extra tabs, Design and Format. They have a whole lot of functions to do with making your graph look pretty, and we'll cover some of those off shortly. The other thing to notice is that if your graph is selected, on the right hand side you've got a series of symbols, and the most important one is the plus at the top. The plus symbol allows you to add anything you might want to add to your graph. So if you want to add anything that isn't currently there, maybe you want to add axis titles because there aren't any, or maybe you want to add a trend line, or you want to add error bars. Anything you want to add, you add by clicking on the plus button. If we click somewhere else on the screen and unselect the graph, deselect the graph, then you can see those things disappear. So if you want them to appear, click on the graph and they pop up. Finally, if we double click on any component of the graph, say the y-axis, then this formatting pane opens up on the right hand side. The formatting pane is extremely useful. It's where we make all of the changes to components which exist on the graph. So there are the two fundamental things to remember. If you want to add anything to a graph, you click the plus button. If you want to manipulate anything on the graph, you use the formatting pane, and you can get to that by double-clicking on whatever it is you want to manipulate. If you're using Excel on a Mac, this is where things start to get a little bit different. You have some new tabs in the ribbon on the Mac too, and one of them contains all of the things that are found in the plus menu here. The addition of error bars, the addition of trend lines, all of that sort of stuff. So just have a nosy around in the ribbon and you'll find those buttons on the Mac. In terms of editing components, it's the same thing. Double click on a component and up pops a box with all the configurable options. Now we are done with this data set. We are going to do some more graphing on data set number 4, and so if you'd like to open that, we'll move on. Welcome to data set 4. This data is also about growing yeast, and this time it really is real data, so there'll be no smiley faces. The experiment was about growing yeast with a supplement, a nutritional supplement, which is supposed to make the yeast very happy and make them grow faster, and therefore to ferment wine more quickly. So we have two things measured. Two things recorded. We have the amount of supplement that we added, and we have the fermentation time. So we would expect that the more supplement we added, the shorter the fermentation time would be, the yeast would ferment the wine more quickly. And so we repeated this experiment 5 times. 5 times we fermented wine with different addition rates of the supplement. So what we've got in this spreadsheet is the same data set laid out in two different ways. On the left-hand side, we've got the addition rate going from 0 to 0.3 litres per 100 litres. and next to it the fermentation times. Now, because we repeated the experiment 5 times, you'll notice that the addition rate goes from 0 to 0.3 and then goes back to 0 and starts again. If we scroll all the way down, we'll see it did that 5 times. There are 5 lots of data there. On the right-hand side, we have the same data, but it's arranged side by side. So on the far left, we've got the addition rate, and then we've got the fermentation times for the first time that we fermented the wine, the second time, the third time, the fourth, and the fifth time. And this is pretty common in science. Typically, you will repeat experiments. If you don't, it's not really that your data really isn't considered to be very robust. And it depends what you're doing, but typically you are going to repeat things a large number of times. So the first thing we're going to do is plot the left-hand side data, columns A and B, in the same way that we just did when we got our smiley face. So we're going to select A2 all the way down to the bottom of the bottom of the data, which is B82, and we're going to click on Insert, and then we're going to click the Scatter again. And there we go. We have our scatter plot. Now, we're going to go ahead and make some changes to this, but before we do, we're going to go ahead and make some changes to this to make it look better, to make it more approachable, and to add trend lines and things like that. First thing we're going to do is get rid of all this dead space below the data. There's no point having the y-axis configured to be showing everything from 0, because from 0 to 40, nothing's happening. So if we double click on that y-axis, then our formatting pane appears as before. Now, let's just have a quick look at the formatting pane. Up at the top, you can see there's a drop-down box that allows you to select which chart component it is that you're editing. Now, we'll leave that because we double-clicked on the y-axis and it knows we're editing the y-axis, but you can change to other components of the graph that way. Now, just below it, there are 4 symbols. The far left one is fill and line. The next one is effects, the next one is size and properties, and the last one is axis options. The axis options one, of course, is only present when you're editing an axis, but all the other ones are still there. The size and properties, which is the third one from the left, is the one where you'll find most of your technical things. You'll be able to change numbers, you'll be able to change the range of things. The others are more about the aesthetics, they're more about changing colours and making things pretty. So now we can change the axis range, and we want to change the y-axis range so that the minimum is 40 and the maximum is 65. And instantly our data looks a lot better. We can also change the x-axis so that the maximum is 0.3. The minimum's okay as it is. And so what we've done is we've blown up the data so that it fills a much larger area of the chart, and this just makes it a lot easier to see the data points and see what's going on. Now we're going to insert a trend line. So as I said before, to add anything to the graph, we go to the little plus symbol, and we get trend line, and we want to insert a linear trend line, and there we go. Now, we've got a trend line inserted. Now, if we want to make any changes to that trend line, if we want to edit it, of course, we need the formatting pane back. So we double-click on the trend line, and there we go. Now, if we scroll down in here, we can see there are lots of different options. They're variously useful for different things. But at the bottom, we can show the r-squared value on the graph. We can also show the equation on the graph if we want to. And those are obviously very useful things if you want to try and infer some statistical significance. The r-squared in particular, this is the only way to find the r-squared. So although it's not good practice to include the r-squared on the graph in this way, it would be much better practice to either include it in the text or, probably best of all, include it in the caption of a graph. This is in fact the only way to find the r-squared in Excel. So what you'd have to do is turn the r-squared on, write it down somewhere, and then turn it off again. So this is a pretty good analysis of the data as it was. You know, we can infer some statistical significance from our r-squared value, but there is probably a better way to show this data. Because we have repeated experiments, we can plot on a graph the average of the 5 repeats, and then we can use some error bars to show how confident we are about that data. So let's go back up to the top and look at the data set that we have here. Now, what we need to do is calculate the average first. And so in the average column, we can use the average function. So we can go equals average, open brackets, select the range of cells we want, close brackets, enter. That was easy. Next to the average, we want to calculate the standard deviation. So we're going to do exactly the same thing, but we're going to use a standard deviation function instead. And the function we're going to use is stdev full stop s. Now just briefly, there are several different standard deviation formulae in Excel. There's stdev.p, stdev.s, and just stdev. The difference between the .p and the .s versions are whether Excel calculates the standard deviation based on whether it assumes you've sampled the entire population, that's the P, or whether you've just got a sample of the population, which is S. Now, in science, you're really only ever going to have sampled, you're really only going to have a sample of the population. So we're going to use stdev.s. You could also just use stdev, which is an older function and was there before the Excel team realized that there were different ways to calculate standard deviations. Now, if none of that made sense, it's because you're not very interested in stats, that's fine. If it did, then you've learned something. Otherwise, always just use stdev. Don't even worry about the .s. And we're going to select the cell range in the same way that we did for the average. And then we're going to close brackets, press enter, and away we go. We can now drag both of those cells down to the bottom, and we have all of our summary data. Now, I'm going to have a quick word about error bars. You may not have come across error bars before, but they are particularly useful in science, and you will come across them at some stage. So error bars are used to show the confidence in data. When you repeat an experiment several times, you'll plot the average on a graph. But you want to show how much spread of the data there is around that average. And you can measure the spread using various different tools. You could use the interquartile range, you could use a standard deviation, you could use a confidence interval. But all of those things give an idea of how spread out the data is. You know where the average is. The average is the average, but you can have an average with the data spread out a long way around it, or an average where the data is all pretty much the same. If you think about stats, think about when you were taught stats, think about bell curves. If you think about the bell curves, the normal distribution curves, you can either have a nice sharp bell curve where all the data is clustered very close to the average, or you can have a very spread out bell curve where the data is a long way away from the mean. And so your error bars give a sense of how spread out the data is. In this data, we're going to use the standard deviation for the error bars, which is why we just calculated that. So let's plot the average that we just calculated against the addition rate. So this is the average fermentation time against the addition rate of the supplement for the yeast. We need to select two columns which are not next to each other. We're used to dragging and selecting a bunch of cells that are all together, but if we use the control button, if we hold down control, we select the first column, hold down control, and then select the second column, we can now select two columns that aren't next to each other. If we then go to insert, and this time we're not going to insert a scatter graph, we're going to insert a bar graph, that one. Now, the reason we chose to insert a bar graph here is to make Excel do something wrong, to make Excel make a mistake, which it has. It's decided that we had two sets of data to plot. with it being a bar graph, it decided that we wanted to plot two series, not that one was the x-axis coordinates. So if you can see down the bottom next to the tall red bars, there are small blue bars. And what it's done is it's plotted the addition rate as a data series. You can see that if you look down at the legend, it's plotted two data series, it's plotted the addition rate, and it's plotted the average. Now, when Excel does mess up like this, and it does from time to time, we need to go into the data series properties and start rooting around, figure out what the problem is, and sort it out. So let's do that now. And the way we do that is by right-clicking on the graph and clicking Select Data, or by clicking Select Data up in the ribbon on the right-hand side. Now, we don't want the addition rate to be there at all as a data series. We want it to be the x coordinates for the average series. And so what we're going to do is first of all remove that. I'm going to remove the addition rate, just like that. Now, what we're seeing in this window here is Excel's way of showing you the data that it's got plotted. The series on the left really refers to the y-axis values. It's saying, here's a range of y-axis values, and it knows that you called them average because it pulled that in from the column heading. Now down the right-hand side of this window, what you can see are all the x values. Now you can see it's just using the numbers 1, 2, 3, 4, 5, and so on. Now it just made those up. It decided that you weren't giving it any x values. This is where it made its mistake. And instead of taking the x values from the column that you selected, it just made up the numbers 1, 2, 3, 4, 5, 6, and so on. So we know those are useless, and what we want to do is tell it to use some specific values instead. So we're going to click on the Edit button. And now what we've got is a box which is quite typical in Excel. You'll see these from time to time. This box allows us to select a series of cells. So we need to select the cells which contain our x values, which are the addition rate values, that's 0 to 0.3. So we select those like that. Now notice that's a little bit awkward here because we can't see behind the graph. We could always go and move that, drag it around, but you can actually drag behind graphs as we just did here, and then we click OK. So now you'll see that we have the same series, that's the same y-axis, the average, on the left-hand side of the window. And on the right-hand side of the window, those made-up x values, just 1, 2, 3, 4, 5, 6, 7, have been replaced by the x values we actually wanted. And so this is a really important window to get to grips with. It's also the hardest thing we're going to cover in terms of graphing, but it is important. If Excel, for example, plots your x-axis values on the y-axis and your y-axis values on the x-axis, which happens sometimes, particularly it happens if you've got your columns what Excel considers to be the wrong way around. It wants you to have the x on the left and the y in the right-hand column. If you've got them the other way around, it'll plot backwards. But you can just open this, this Select Data window and click this little button in the middle here, and the two arrows on either side sort of demonstrate that what it's going to do is it's going to take the x-axis values from the right-hand side and turn them into a series on the left-hand side. And it's going to take the series, which is basically a collection of y-axis values, and it's going to put those into x-axis values on the right-hand side. So although they are displayed differently, they're not displayed as x and y coordinates in this window. You can think of the left-hand side as y and the right-hand side as x. So if we click OK, then our graph has changed. We've got rid of that, that extra series, that silly series that really wasn't a series, and all of our y-axis values look good and make sense. So now we've got those plotted successfully, we are going to add error bars. And the way we're going to do that is just like we add anything else. We're going to add error bars by clicking on the plus symbol. So these error bars are useless. They're absolutely meaningless. Excel has a method of calculating error bars whereby it calculates the standard deviation and the standard error, and then it plots either the standard deviation or the standard error depending on which you tell it to. The default is the standard error, and it gives you these pretty error bars, but it doesn't actually know where any of your data is, and so the standard error and the standard deviation that it calculated are magic. They are absolutely calculated from nowhere. Even Microsoft officials don't seem to know where they're calculated from. So basically, the take-home message is don't ever let Excel plot its own error bars because it hasn't got a clue what it's doing. So what we're going to have to do is we're going to have to tell Excel what data to use for those error bars. So if we double click on them, the formatting pane will open up again. And if we scroll down to the bottom, we can tell it that we want to use custom data for the error bars, and then we can tell it where the data is. Now we can tell it the positive and negative error bars separately. Usually though, they're the same distance from the averages. And so we can, in both cases here, delete what's already in the box and select our standard deviations that we calculated. Do that for both the negative and the positive error bars. And then when we click OK, we get real error bars. These are proper standard deviation error bars that make sense and are valid. Now, what's particularly important is to make sure that whenever you use error bars, you tell your audience what the error bars are. So when you put this graph into a paper, you'd have to say error bars equal standard deviation. Better yet, you'd say error bars equal 1 standard deviation. And this is really important because error bars could be standard deviation, they could be standard error, they could be confidence interval, they could be interquartile range. So whatever they are, you do need to tell people. The other thing to note is that Excel's calculating these error bars, it's plotting these error bars as an offset from your mean. And so if you had a mean of 50 and error bars were supposed to appear at 55 and 45, your error bar values would both be 5. They wouldn't be 45 and 55. And that's really useful because here we've calculated standard deviation and we've plotted our error bars at 1 standard deviation above and 1 standard deviation below the mean. But if you wanted to do 2 standard deviations above and below the mean, you could do that. You could put a multiplier of times 2 in your standard deviation formula, and that would happen. Okay, so we've finished with this graph, and we are going to go on to the next dataset, dataset 5. And so if you'd like to open that up, then we will move on. Now this dataset contains information about fermenting wine again. This time it contains a record of the sugar concentration dropping in the grape juice that's turning into wine, and the alcohol concentration going up. Now, of course, the two are related because yeast turn sugar into alcohol during fermentation. And these readings were taken at many time intervals throughout the fermentation. So if we select those 3 columns and we plot them on a scatter graph, Excel will make sense of this. Now, it's important to remember that Excel makes sense of this because in our first column are the X values, and then our Y values are in the subsequent columns. Now, if we had them in a different order, we'd have had to go into the select data window as we did before and make sense of those. And we'll show you that in a little while. So here is our graph. Now, you can see there's a problem with it. The ethanol values are measured in percentage, and so they go up to about 14%. And the sugar concentration is measured in grams per litre, and so it goes up to about 250. And that means that the two don't show very well on the same y-axis. The alcohol values are way down the bottom, they're not really very helpful. So let's show you a neat little trick. What we can do is we can plot the alcohol values onto a secondary y-axis. The way we do that is we do double click on any one of those alcohol values. So we're selecting the series, and the formatting pane pops up, and we can tick secondary axis. And that's it. It's as easy as that. We now have one axis with the alcohol values attached to it, and one axis with the sugar concentration attached to it. Now, there is one problem here, and that's that there is no way of telling which axis is associated with which series of data. And so the way to fix that is to format your axes so that they're color-coded. This is quite easy. So if we double-click one of the axes that we want to format, our formatting pane opens up. And if we go to the little tab that has a button that looks like a paint pot, then we can select the color of the text, and we can make it red. And lo and behold, it now makes logical sense. And we can do the same with the other one and make it blue, but we don't need to bother going into that here. You can also add labels to the axes, of course, which aren't here currently. We can use the plus symbol to do that. And you can do that in your own time. So what we'll do now is we'll close this graph. We'll delete this graph, sorry. So if we click on it and then hit the delete key, it'll go away. And we'll scroll back up to the top of the window. And what we're going to do is rearrange this data, and we're going to show you what might happen if the data was in a different order and we plotted it. So we're going to cut column A using Control X. We're going to paste it into column D using Control V. And then we're going to go ahead and we're going to replot our graph. So when we plot this graph, we're going to select columns B, C, and D. And everything's going to go horribly wrong. Excel is going to use the first column, so it's going to use sugar as the X values, and so it's plotting the other two, the alcohol concentration and the hours, as a function of sugar concentration, which is very confusing and doesn't help anyone. So in order to try and fix this, what we're going to do is go to the Select Data window again, and you can see here what it's done. It's plotted time, and it's plotted ethanol, and it's plotted them both with sugar as the X. So if you click on either of those series, you can see that the X-axis values are sugar on the right-hand side there. It doesn't say that they're sugar, but they're those high numbers, so we know that those were the sugar values. The easiest way to fix this, and probably the best way to teach you how Excel figures out where the data is to actually just remove both of those series and add them again. So we'll remove them both, and then we'll click Add to add a new series. And we get this little box, and this little box is very helpful. We can put in a series name, so let's do the sugar one first. We can type in sugar, and then we can select the X values, which is time, and then in the Y values. Now just remember we need to clear what's in that box, and then we can select the Y values, and so that's the sugar. And then we can click OK. And we now have a series called sugar, which has the appropriate X values on the right hand side. So now all we need to do is do the same again. Click Add. This time it's going to be our alcohol, so we can type alcohol or ethanol, whichever you prefer. We can select the X values, which are still time. And then again, deleting what's in the Y values box, we can select the Y values, which is the ethanol concentration percentage. Click OK. Now both of our series are there, they both make sense. Click OK, and we're back to where we were before. Of course, we can add the secondary axis again, but the point is that we've made sense of the data. So you can in fact insert a scatter graph with no data and then add your series manually, which is often a useful thing to do if your data is maybe spread out around a spreadsheet. It's a bit complicated. But what you can see from this is how Excel interprets data, how it calls some Y values a series, and the associated X values can be either made up or they can overlap or whatever. So that's it for data set number 5. If you open up data set number 6, then we'll continue. So this is data set number 6. This is the final data set. And we're not actually going to go through this and plot a graph, but you can do that yourself now. This is a great data set for you to have a play with. You can see that we've got repeated data. We've got the temperature of water, and we've got measurements of its density. And we've done this experiment 6 times in fact. And so you can use that data to calculate some summary data, some averages, and then you can decide what you would like your error bars to be, whether they're going to be standard deviation again, or whether you're going to look up some other functions in Excel like standard error, confidence interval, whatever it might be. And so that brings us on to how you can look up these new things. Now, if you go into the Formulas tab, you will see that Excel has some nicely prearranged formulas for you. They're grouped into things that into useful groups like financial and things like that. And on the far left-hand side, there's the Insert Function button. Brings up the function browser if you click on it, which allows you to look down the list of functions. It gives you a bit of information about each one, tells you how they work. And that's quite helpful. And we'll just close that for a moment. The other really helpful thing in Excel is the help. You can get to the help either by pressing F1 or by clicking the little question mark, which is up here in the top right corner. And if you click on that, then you can type a search term into the box at the top. Maybe you want to look up some information about a confidence interval. So you can type in confidence interval. And you'll find that you get some nice articles from Excel Help telling you about confidence intervals and how to calculate them. Finally, the other thing that you can do is, of course, go online. If you Google confidence interval in Excel, you'll find very quickly information about how to calculate the confidence interval. And you already know now that it's going to come down to a function. There's going to be a function called confidence. You're going to open some brackets. You're going to write equals confidence, open brackets, and then put in something, some values, some information there, and tell it what you want. And so what we're hoping is that through this tutorial and more importantly the actual in-person tutorials that the Science Society has run, we have taught you enough of the basics of Excel that you can go away and you can look things up online and you can look things up in Excel Help, and that they will make sense to you. And so you've got the foundations to find out what it is that you need at any given time. If there's anything else we can help you with, then do get in touch and we'll try. Otherwise, we'll see you at the next exciting Science Society event, whatever that may be, and good luck with Excel.